124.4 billion. I mean, that is just a massive, almost incomprehensible number, right? To put it into perspective, we're talking about enough to fill nearly 50 million Olympic swimming pools. But in the context of our explainer today, it represents something far more valuable than dollars or gold. That number is 124.4 billion cubic meters, and it's the estimated total surface water potential of just one single nation.
Welcome to today's explainer. I am absolutely thrilled to guide you through this because we are looking at one of the most fascinating geographic setups on the entire planet. We're exploring a country where a unique blend of high-altitude geography and heavy rainfall creates staggering water resources. We're talking, of course, about Ethiopia, widely known as the Water Tower of Eastern Africa.
Okay, let's dive into this. Here's our roadmap for today. First, we'll cover the Eastern Water Tower. Second, the three major drainage systems. Third, rivers, lakes, and groundwater. And finally, tapping the huge potential. All right, moving into Section 1, the Eastern Water Tower.
So, what does this actually mean? Well, it all comes down to a perfect geographical storm. Ethiopia earns the nickname Water Tower of Eastern Africa because of its incredibly diverse topography paired with heavy, consistent rainfall. You kind of have to imagine the country as a giant, naturally occurring water collector. You've got these massive, elevated highland plateaus sitting right near the equator. When the heavy seasonal rains arrive, these high-altitude regions literally catch the water and distribute it outward, making the country the primary highland source for numerous major transboundary rivers that end up supplying the broader region.
Let's move on to Section 2, the three major drainage systems. And this brilliantly illustrates exactly where all that water goes. You see, the drainage patterns of Ethiopia aren't random at all. They are entirely dictated by the topography. The outward-sloping plateaus push water away to the west and southeast, and right down the middle you have the inward-sloping Rift Valley creating its own isolated internal water system. These structural features basically divide the landscape perfectly into three distinct drainage systems.
When we actually break down the total volume, the disparity is massive. The western drainage system absolutely dominates the whole shebang, carrying a staggering 60% of the nation's annual water flow. The southeastern drainage system handles about 25%, and the Rift Valley and other inland drainages capture the remaining 15%. So the vast majority of that 124.4 billion cubic meters is just rushing westward.
Now, zooming in on that dominant western system reveals several major basins, like the Tekeze, the Borowakobo, and the southward-flowing Jibe. But the absolute giant of the region is the Abe, which you probably know as the Blue Nile. This basin alone carries 54.5 billion cubic meters of water. It is the largest basin in the country, both in terms of the area it covers and the sheer volumetric discharge it unleashes.
And the journeys these rivers take are full of incredible contrasts. The Abai embarks on this epic 1,450-kilometer journey westward to eventually join the White Nile in Sudan. But then look at the Wabi Shabale in the southeastern system. It's actually the longest river in Ethiopia, yet it mysteriously disappears into the sands of Somalia. It literally never reaches the ocean. Meanwhile, rivers like the Awash and the Rift Valley never leave the region at all, ending their flow in local marshes and lakes like Lake Abe.
On to Section 3, rivers, lakes, and groundwater. If you had to describe Ethiopian rivers in a few words, wild and energetic would be pretty spot on. Almost all of them originate high up, over 1,500 meters in elevation. Because of the distinct wet and dry seasons, they experience extreme fluctuations. During the wet season, they burst their banks with incredible force, carving these deep, dramatic gorges into the earth and rushing over numerous steep rapids before crossing borders as transboundary rivers.
But you know, water in Ethiopia isn't just rushing rivers. There's a fascinating duality here. Just compare the highlands to the Rift Valley Lakes region. Up in the highlands, you have towering elevations, high rainfall, and those steep, gorge-carved river profiles pushing water outward. But drop down into the Rift Valley, and the environment totally flips. You're in a sunken, tectonically formed depression where water drains inward. Down there, evaporation is incredibly high, catchment areas are small, and instead of rushing rivers, you get this beautiful linear chain of lakes. And these tectonic lakes, which were mostly formed during the Quaternary period, are a study in extremes themselves. Up in the highlands, Lake Tana sprawls across a shallow depression to be the largest lake in the whole country. But down in the Rift Valley, Lake Shala plunges to these dark depths of 266 meters. In stark contrast, Lake Ziwe, right in the same system, is incredibly shallow, reaching just about 8.95 meters at its deepest point.
Before we leave the physical resources, we can't forget what we can't see. Beneath the surface, there's a hidden reservoir.
While exact estimates do vary, research indicates there's between 12 and 30 billion cubic meters of groundwater sitting beneath the surface. It's a massive, largely untapped asset compared to the rushing rivers up above.
Finally, Section 4, tapping the huge potential.
The grand economic opportunities here are staggering, but they definitely come with unique challenges. For instance, there's an estimated 5.3 million hectares of irrigation potential. However, the rugged, steep terrain makes actually realizing this quite difficult and expensive. And because of those rapids and gorges we talked about earlier, transportation on rivers is extremely limited. Really, only the lower Baro River is truly navigable, alongside some small-scale transport on Lakes Tana and Abaya. Still, the fishing industry already yields 31.5 thousand tons annually, and the sheer scenic beauty of places like the Blue Nile Falls offers massive recreational and tourism value. But the ultimate game changer here is power.
So the crucial point is the 45,000 megawatts of exploitable hydroelectric capacity. Because the rivers drop from such high elevations, the kinetic energy is just massive. Consider this, 6,400 megawatts. That is the planned output of just one single project, the Grand Ethiopian Renaissance Dam, or GERD. Along with other completed projects like Giljugib III, which provides 1,870 megawatts, the country is actively working to transform the rushing water of the highlands into the electricity that powers modern development.
We've seen the incredible volume of water that makes this region unique. But there's still an enormous gap between Ethiopia's massive physical water endowment and its fully realized economic development. This matters because whoever harnesses this water shapes the future of East Africa. So, with 45,000 megawatts of power waiting in its rivers, how quickly will the water tower of East Africa transform its economy? It is a fascinating question of geography meeting human ingenuity. Thanks for exploring this with me today on The Explainer.